Okay, so I'm going to be going over each of the page of the test for those of you who did really poor so that you can earn some points back on your test. So this will be in lieu of test corrections that you might do otherwise. So one of the things that you do need to do is be sure that you write down, if you want the points, you write down everything that I write down, and also things that I tell you that may not be written down, I'm also going to expect to see on your paper. So first off is we are going to talk about what the degree of the polynomial is, because that's the first question. It says state the degree. And by definition, the degree is the highest power or highest exponent of your polynomial. Now, usually when we look at this, we have it all multiplied out. And so you might have something like, x cubed plus 2x squared plus x minus 1. Well, in this case, our highest power would be the 3. So our degree would be a 3. We might also, have 2x4 minus 3x plus 5, and in which this case our highest power is a 4. So that would be degree 4. Okay, so this one would be degree 3, and this would be degree 4. Now the problem with the one that we have up here is it is not written in standard form. Okay, this is called standard form. Okay, this is called, guys, factored form. In other words, all the work pretty much have been done for you in terms of graphing, finding the x-intercepts and so forth. It's all been done for you. So you don't ever want to multiply this back out. Now, back to our question, what's the degree of it? Well, the easiest thing to do is just come up here and look at all of your powers. So this x is to the first power. This x, when I square it, will be an x squared. And this one would be an x1. So what I have is an x1, an x2, and an x1, which means I have an x4 polynomial, which means I have degree 4. Okay, so my degree is equal to 4, and that was your answer to A, and that's how you find it. Now the next one said, what information about the behavior of the graph? Okay, behavior of the graph means what is the graph doing? Okay, your behavior is what you're doing, okay? Do you know just by looking at the factors? And again, we talked about two things in terms of when we look at our factors. We looked at it if it had an even multiplicity, okay, it would touch and bounce at that point. Okay, and if it had an odd multiplicity, then it would go through that intercept. Okay, so this one is going to touch and bounce at the intercept, and the second one is going to go through. So again, back to our problem here. That x is to the first power. The x plus 2 is to the first power. So at, and I accepted it either way, but if you said at x equals 0 and a negative 2, it will go through. Okay, but you needed to tell me where. Just saying it's going to go through is not giving me enough information. Where is it going to go through? And all of these questions, guys, are leading you to your graph. Okay, your next one up there, what's left is x plus 5, and it is squared. So it has an even multiplicity, which means that at x equals a negative 5, it will touch and bounce. Okay, so don't just say go through, it will touch and bounce. You need to be more specific on that. Okay, so that was the answer that I was looking for. Okay, C. I feel like we went over this so many different times, but I give you the beginning and I ask you what happens. Okay, and if you'll remember, guys, we talked about, again, something for you to write down. If it is an x3 power, or a 5, or a 7, any of the odd powers, okay, so we could say odd exponents, okay? And now I call it the disco. I was trying to think what Mrs. Johnson called it the other day. She had a name for it, but the S maybe, I don't know, I can't remember what she called it. Anyway, but I call it the disco because that's my generation, you know. But I know it's going to look like this, okay? That's all your odd exponents. Now, there's going to be different things that happen inside here, but as far as the end behaviors, this is what's going to look like. If it is an even exponent, okay, and hopefully you know odds. Odds is if it's a 1, 3, 5, 7 power, degree, okay, we'll put it even there, degree. It's going to look like that. If it's a 2, 4, 6, 8, so forth, that's even degree. It's going to look something like, I say a W, it actually could look like a parabola, but either way, you're going to have it going up, okay? Now, again, that's if it's positive, okay? That is if A is greater than 1, A greater than 1. We took these notes down already. If A is less than 1, then it's going to go the opposite direction. If A is less than 1, it's going to go, again, down. So when I ask you, look at this graph, what is it going to do? Well, I'm coming back up to my problem right here. We're a degree 4, which means I'm over here looking at this. So is it a greater than 1 or a less than 1? Again, I'm going to come back up here. What I'm talking about is the number out in front. Well, you don't see 1, but it is an understood 1. Okay? Therefore, 1 is greater than, I should say greater than or equal to 1. Sorry, that's my bad. Okay? So it is a 1. Therefore, it's going to look like this. It's going to keep going up, up, up in both cases. So positive infinity, positive infinity. Now, I'm still having a couple of you guys who are just putting infinity. And I've told you multiple times, we always put the positive and we always put the negative. We are specific about which one it is. Rarely do you see it where it just says infinity. It's positive or negative. Be specific on that. Okay, our next is D. Okay, and D says state the y-intercept. Now, here's another issue we're having. Guys, and I'm picky about this. You know, you may go to any other teacher and they're not. I am, okay? I'm kind of black and white on some definitions. And the definition of the y-intercept, it is the point where it crosses the y-axis. And so it is a point, okay? We've always talked about if it's a y-intercept, it's where x is 0. Now, how do you find it in this problem? So I'm going to go back up here to my problem. Look at what I have here. If I multiply this out, guys, I'm going to have 5 squared times 2, okay? So 50, and a lot of you gave me that. But guys, here, you've got a 0. So really it is 0 times 5 squared times 2. And let me go write that all out again so you see what I'm talking about. So it is x times x plus 5 squared times x plus 2. So when I put my 0 in for x, that's what you have. And most of you ignored that 0 right there. So I get 0 times 5 squared times 2, but I don't really care about that because 0 times anything is 0. Okay? So your y-intercept is 0. So if you need to, put your points in and get it. Okay, so the next one is E. And it asks for the real zeros. Okay? Now, those of you who don't know what real zeros are, had several people ask, then a couple of things. One, the worksheets all ask for real zeros. Two, the video that I gave you, I explained to you that there are multiple words that all mean the same as real zeros. So real zeros are basically the same thing as our x-intercepts. Okay? They're the same thing as our solutions, and they're the same thing as our, I just lost my train of thought, roots. Okay? All of those mean the same thing. Okay? So require, whoops, that's a Q. Require same work. Okay? Now, technically, the only thing different would be how you write your answer. Because typically for the zeros, we just list them. Okay? So in my problem above, they would have been 0. Okay? That's what that is. Because remember, whoops, sorry. We set each of our factors equal to 0. So x equals 0, x plus 5 equals 0, and x plus 2 equals 0. So my real zeros are 0, -5, and 2. Okay? Now, if I ask you for the x-intercepts, then technically you need, they again are points. 0, 0, -5, 0, and 2 zeros. And some of you gave it to me as intercepts, and that's fine. I took it that way. That's not a problem. I would rather you write it that way than not write it either of those ways. If you want solutions, again, you could write it, typically it would be written this way, or you could actually use our set notation. Okay? Now, I did say one more thing there. It said state the multiplicities. Okay? And remember, our multiplicities we get because this is to the second power. And what that is telling you is the -5 appears twice. Okay? So I'm going to say -5 with a multiplicity of 2. And be sure when you write your multiplicity, I know which value it is going with. You can't just say 0, -5, 2, multiplicity of 2. I need to know which one it goes with. Okay, so that is most of our information that we have. And now I ask you to sketch the graph. So we're going to go to our graph. And I'm going to put in my intercepts. So I have 0, 0. I have a -5, 0, 1, 2, 3, 4, 5. And I have, whoops, I dropped a negative there. My bad. Let me get that back on there. So -2, -2. -2 as my other one. Okay? Right there. Now, what did we say earlier? I'm going to go all the way back up to the top, right here. It said at 0 and -2, we're going to go through, and at a -5, we're going to touch and bounce. So remember I told you, I put the little B there, meaning, hey, don't forget to bounce off of that. If you want to go through and through, or whatever notation you use, or if you just want to do the B, that's fine. We also said in this piece that it's going to look like this. So all I need to do now is sketch in my graph. So I know it's going to come down, it's going to touch and bounce off of that, it's going to come back up and back down, and then back up. I kind of missed that point there just a little bit. So a couple of things, guys. One is this graph curves at all times. So it should never look like you have a straight line anywhere. It's going to curve at all times. Okay? That's F. Okay? G asks for the local minimum and the local max. And I told you, since you were not using a graphing calculator, that all you need to do was kind of tell me the interval in which you would find it. So I didn't need you to get specific. So this would be my local max, and I'm going to find it somewhere between here and here. And that would be your -5 and a -2. So the other thing is, guys, remember when we do our interval notation, okay, on the left is always the smallest value. And on the right is always the largest value. So some of you wrote it as a -2, -5, and that's in the wrong direction. I didn't count it off, but you need to start doing it in the correct order, okay? That's one of those things that if I give it to you on a final, I might put it in the wrong order just to see if you're paying attention on a multiple choice question. Your local minimum would be down here. This is a minimum, but definitely this one's going to go lower because this one touches and bounced off. So that is going to be between the -2 and 0. Okay, so that is your first problem with all of the work that is required for it. And again, I did put extra stuff on there, but you need all of that information organized and written on your paper.